let us find a transfer function to an electrical system using the circuit, drawing block diagram for the same circuit and drawing signal flow graph for the same circuit. So either of these given to you, then how to find a transfer function. Let us consider an example which was appeared in the previous competitive exam. It is a simple circuit. We have discussed even earlier to find out the transfer function. As you know, input voltage is Vi, output voltage is V0. R and C are passive elements. Then there is a current I that flows through the circuit when Vi is applied. So for this circuit, I was mentioning that the basic laws you have to use and develop equations for input voltage as well as output voltage. Input equation is Vi R into I plus 1 by C integral I dt. This is using KVL. This equation can be written. Now you can apply Laplace transform to this. When you apply Laplace transform, you get this equation. Now you can have this as I of s into R plus 1 by Cs. This is input equation Vi of s. Similarly, an output equation can be written as V0 of s is equal to 1 by Cs into I of s after applying Laplace transform. So this is input equation and this is output equation. Now in order to get the transfer function, as you are aware that V0 of s by Vi of s, you will get 1 by RCS plus 1. So this indicates that RC circuit forms a pole with a time constant of RC. So this can be written as 1 by tau s plus 1, where the pole is at s is equal to minus 1 by tau. Now you can also get this equation Vi of s is equal to R into I of s plus this 1 by Cs into I of s is nothing but voltage across the capacitor. So it is nothing but V0 of s. We can write. So I of s can be written as Vi of s minus V0 of s by R. This is the current equation. And this current, when it flows through the capacitor, an output voltage is developed. So V0 is equal to 1 by Cs into I of s. Let us see now. You have got the transfer function anyway. It indicates, RC circuit indicates one pole at not origin but at s is equal to minus 1 by tau. Now let us draw the block diagram for this. Input voltage Vi and output voltage is V0, and if I want to get a current I of s, so this must be V0, this must be V0 of s, this must be Vi of s. So plus minus, you can see here Vi of s minus V0 of s divided by resistance gives the current. So I want to have a difference of Vi of s minus V0 of s from summing point. Now this output of summing point will be difference of this. Now I apply here 1 by R. So as you know that the output here is Vi minus V0, that is given to this block 1 by R, that is the gain of that block. So you will get here current. So current can be obtained. You can see that this equation is represented in the form of block diagram. Now this I of S, when it flows through the capacitor, output voltage V0 is developed. So that way you can say here 1 by Cs times I of S, you will get V0 of S. So this is the feedback you have here. So the difference then multiplied by this block, get current, multiplied by this block, you get V0. So this is same circuit, but the equations are represented in the form of block diagram. So as you know that if same electrical circuit is represented in the form of block diagram, then you may be asked to find out the transfer function for this system which is described by block diagram. So as you know, now these two blocks are in cascade. These two blocks are in cascade. So you can have a single block 1 by RCS, 1 by RCS. So you have V0 of S, and this is the summing point. You have V0 of S, Vi of S as usual with plus, minus, and then this one. This block diagram is reduced to this one now using rule 1 when the blocks are in cascade. Now you can see that this is a loop. Loop consists of a summing point, a block, and a takeoff point. So you can eliminate the loop, rule 3. If you remember block diagram rule 3, you can apply here elimination of feedback loop with feedback H equal to 1 here, and you can consider this as G. So what is V0 of S by Vi of S here is nothing but eliminating the feedback loop, whatever the gain you get. So this is G, this is H. So G by 1 plus GH is the formula. So you can write here 1 by RCS, that is G, by 1 plus again GH. So again 1 by RCS. H is 1 anyway because it is unity feedback, no component. Now you can get this 1 by RCS plus 1. So you can see that this is nothing but 1 by tau s plus 1. This is the transfer function you got when block diagram is given, and when electrical circuit is given, you have got here the transfer function same. Now the another way is to draw the signal flow graph. Once the block diagram is drawn, you can actually get signal flow graph easily. Signal flow graph, it consists of only nodes and branches. As I indicated in the last class that nodes are probably voltages or currents, and branch consists of gain. That gain may be a resistance or impedance or admittance. Remember 1 by Cs is not a capacitance. So it is the impedance, Laplace impedance 1 by Cs. So now let us draw the signal flow graph for this block diagram and see that what is the transfer function. So let us draw the signal flow graph for this block diagram. As I indicated, when block diagram is given, you should identify the nodes first. For this input variable, node 1, summing point, node 2, and takeoff point, node 3, output variable again 4. So there are 4 nodes identified. Node 1, node 2. You can see here node 1 is the input voltage applied, and node 2 is the summing point. So between node 1 and node 2 there is no block, so I can say that the gain of this path is 1. Now from node 2 to node 3 you can see that there are 2 blocks. Actually this resultant is already seen here as 1 by RCS. So you can mention that this between 2 and 3 there are 2 blocks in cascade. So you can just get as 1 by RCS the gain of that. Then from 3 to 4 again there is no block, so the gain of that can be treated as 1. Now you can see that 3 is connected back to 2. So the gain here is 1, no block, with negative sign. So 3 and 2 are connected with -1 gain. So this is the signal flow graph for this block diagram. Obviously signal flow graph looks simple when compared to the block diagram. So very simple signal flow graph you have got, and you need to apply Mason's gain formula to find out the transfer function or overall gain between V0 of S by Vi of S. So V0 of S by Vi of S is equal to, now the Mason's gain formula, 1 by delta sigma P k delta k, where k is equal to 1 to number of forward paths. If you remember, P suffix k is the gain of kth forward path. Forward path is nothing but path connecting the input and output. So look at here, the forward path is this. Path travels from node 1, 2, 3 and then 4. So the only one forward path exists between input and output. So I can say that this formula I can write as 1 by delta into P1 delta 1. So it depends on how many forward paths that exist in the given signal flow graph. So now let us find out what is P1. Gain of the forward path, simply multiply 1 by RCS and 1. So P1 is 1 by RCS, and delta is 1 minus sum of the loop gains. So there is only one loop that exists here between 2, 3 and back to 2. It is a loop. You can see the direction of the path, that this is a loop. So what is the gain of this particular loop? It is 1 by RCS into -1. So minus 1 by RCS. There is only one loop that exists. Now this can be written as 1 plus 1 by RCS. 1 plus 1 by RCS. Now what is delta 1? Delta 1 is same as delta, but not touching the first forward path, means 1 minus individual loop gains which are not touching the first forward path. So there is only one forward path and this loop is anyway touching. So I can say there is no non-touch loop exists in the graph. So this is delta 1 is equal to 1. Now simply substitution. The formula for the transfer function according to Mason's gain formula, you can substitute now 1 by this one, 1 plus 1 by RCS, and P1 is 1 by RCS and delta 1 is 1. So this also leads to 1 by RCS plus 1. So same information, that when electrical circuit is given, you got 1 by RCS plus 1. Block diagram, same circuit is represented in the form of block diagram, you got the same, and for signal flow graph you got the same. So the number of questions that can be generated from this problem is You may be given electrical circuit, draw the block diagram. So you may be given electrical circuit and you may be asked to draw the signal flow graph and then verify the transfer function. So this is the advantage of having signal flow graph, very easy to find the overall gain of the system. Let us see this problem. It was given in the previous GATE exam, that it looks like a simple block diagram. I say that it is simple because not too many summing points and too many blocks and takeoff points. So hardly you have 2 summing points, 2 blocks and 2 takeoff points you have. But you can't have, you see that, are there any blocks in cascade? Are there any blocks in parallel? Or can you eliminate any feedback loop? So first 3 basic rules cannot be directly applied, so I say that it is a complex block diagram. So for this, you can see the beauty of a signal flow graph. When you draw that signal flow graph, it looks very simple and you can find the transfer function very easily. So let us draw SFG. So the first step you should remember to draw the signal flow graph is you need to identify the nodes are nothing but variables. So input variable as a node 1, there is a takeoff point here, call it as node 2, there is a summing point, call as a node 3, there is another summing point 4, fourth node, and takeoff point 5 and output variable 6. All takeoff points, all summing points and input and output nodes must be given numbering in the block diagram. So all these 6 nodes you need to represent now 1, 2, 3, 4, 5, 6. So the numbering must be given first and then you can now add the nodes with respective gains. Between 1 and 2 there is no block. So you can say simply signal is traveling from 1 to 2 with a gain of 1. Between 2 and 3 also no block. So it is also 1. But between 3 and 4 there is a block and it is gain given by 3 by S. So between 3 by 4 you must write 3 by S. Now between 4 and 5 there is a block again whose gain is given by 2 by S plus 2, 2 by S plus 2, and between 5 and 6 no block, so I just consider it as 1. I mean to say 5 and 6 are same because the gain is only 1, so you can consider 5 as well as 6 both are one and the same. But just for the convenience to represent that input variable and output variable and the path that is connected is called as a forward path. So now you can see between 2 and 4 there is a path which you can see that it is a forward path. It's going from 2 to 4. So you can just join this 2 to 4, no block, so gain is 1. And between 5 and 3 again there is a path but no block, so whose gain is 1, feedback is 1. So between 5 and 3 with minus 1 because it is minus here, 1 here, so minus 1. So this is the signal flow graph for this particular block diagram. This is SFG, whereas this is block diagram. Now it's very easy to find out the overall gain of the system using Mason's gain formula. As you know the formula, Mason's gain formula, you need to find out the number of forward paths first. So let us see. Number of forward paths means path connecting input and output nodes. So let me see the gain of first forward path connecting 1 to 6 through this path. So 1, 2, 3, 4, 5, 6 is the path. Path is 1, 2, 3, 4, 5, 6. And what is the gain? You need to just multiply the gains of individual branches along the forward path. So 1 into 1 into 3 by s and 2 by s plus 2. So it is 3 by s into 2 by s plus 2 is the gain of first forward path. It is 6 by s into s plus 2. There is another forward path that exists here. It goes from 1 to 2, then it goes via this fourth node, then 5 and 6. So what is the path? 1, 2, then it goes to 4, 4, 5 and 6. So what is its gain? You can see from 1, 1 and 2 by s plus 2 into 1. So P2 is the forward path 2 and its gain is 2 by s plus 2. So no other forward paths exist. Remember, while identifying the forward path, no node should come more than once, connecting input and output variables. So this is P1 and P2. Now let us identify the number of loops. So number of individual loops we need to identify. Loop is nothing but it's a path, closed path, starting from a node, travel and terminating at the same node. So this is 3, 4, 5, again back to 3. That is called a loop. And what is its gain? You can see 3 by s. The gain of the loop 1 is 3 by s into 2 by s plus 2 into minus 1. So this is minus 6 by s into s plus 2. So you have got a loop. There is no other loop. Remember, this is not a loop. It looks like a loop, but it is not a loop because of the reason that you see the path, it is going from this 2 to 4, and to say that this as a loop, there should be arrow from 4 to 3 and back to 1. This is a loop. This is a loop because it starts 3, 4, 5 and path you can see back to 3. So don't look like that this is a loop. Okay, don't be under impression that it is a loop. Okay, it is not a loop, whereas this 3, 4, 5, 3 alone is a loop that exists here. Now we need to apply Mason's gain formula to find out the y of s by x of s is equal to 1 by delta into P1 delta 1 plus P2 delta 2. Two terms exist in this because there are two forward paths. If 3 forward paths are there, then there are 3 terms in that. Now P1 and P2 already indicated here. Now what is delta? Delta is 1 minus sum of the loop gains. Sum of the loop gains. So there is only one loop here. It is already given that minus 6 by s into s plus 2. S plus 2. So this is 1 plus 6 by s into s plus 2. Delta. Now what is delta 1? Delta 1 is 1 minus sum of the loop gains which are not touching the first forward path. You can see the first forward path and this loop is actually touching. Touching means even if there is one node common between the loop and forward path, we say it is touching. if you see that the path for the first connecting input and output 1, 2, 3, 4, 5, 6 are the nodes, whereas for the loop 3, 4, 5, 3. So even one number is enough matching, so we say that loop is touching the forward path. So there are no loops not touching the first forward path, so 0, so it is 1. Similarly, delta 2 is 1 minus the loop gains which are not touching the second forward path. So it is also not possible here, and the only one loop, it is touching both the forward paths, so it is again 1. Now it is simply substitution, observation then substitution in the Masson's gain formula. So it is given by y of s by x of s is equal to 1 by delta into P1 delta 1 plus P2 delta 2. So simply substitute P1, P2 and then delta 1 and delta 2 and get the transfer function. So that way you have an advantage of signal flow graph for the given complex block diagram. You can try this block diagram reduction rules and find the overall gain for this. It will be really complex, because if you see this block diagram reduction rule, you may have to shift this takeoff point to after summing point, and you may have to shift this summing point to after a block. Circuit becomes further complicated, whereas if you draw signal flow graph, it is reducing our burden and easily you can find out the overall transfer function. This is the block diagram we have discussed in the previous example, drawing a signal flow graph and finding the y of s by x of s. And in one of the question papers, it also appeared like the output of this summing point. The output of this summing point is E of s. E of s. So what is E of s by x of s? So there may be a question you may get like, find out the ratio of E of s to x of s. Means you need to consider that x of s as input and this summing point, and this will be the output, because I want to know the ratio of E of s by x of s directly. So that time, how to redraw this block diagram again, because y of s is not the output, now E of s. You may get a question to find out the ratio of E of x by x of s. Now you can see that this entire thing will become a feedback. Three by s, and there is a summing point, and for that summing point the another signal is coming from x of s with negative polarity, negative sign, minus, and this 3 by s is also coming here with plus sign. After that, this 2 by s plus 2, here you have 2 by s plus 2 is the with minus sign. So this will be the circuit now. No y of s exists. No y of s exists in this second case, because the question is E of s by x of s. So you can simply ignore this particular y of s, and the circuit or the block diagram is redrawn. Now it is also not that simple to find out using block diagram reduction rule, but signal flow graph will makes us to get the ratio E of s by x of s in an easy manner. So for this, again you need to put the nodes starting from input node 1, takeoff point 2, summing point 3, takeoff point 4, output node 5, and summing point again here 6. So number of nodes exist in the block diagram that is redrawn to find out E of s by x of s are 6. Those 6 nodes you need to represent now 1, 2, 3, 4, 5, and there is a 6th node anyway here, 6th node. Now you just join them with the respective branch gains. 1 and 2 are joined, no block in between whose gain is 1, and between 2 and 3 no block, again gain is 1, between 3 and 4 also no block, so the gain is 1, and between 4 and 5 again it is 1. Now between 4 and 6 there is a block 3 by s. So this one there is a path, and this gain is given by 3 by s with positive sign, Now between 6 and 3 there is another block. So between 6 and 3 whose gain is 2 by s plus 2, and 2 and 6 are joined with this forward path, the gain is 1. With minus sign here, so put minus. So this is the signal flow graph for this block diagram. So now it's only an observation. You need to identify how many forward paths exist between input and output nodes. So there is a first forward path P1, you can identify this. So the gain of that particular forward path is 1 into 1 into 1 into 1. So it is simply 1, the gain. There is another forward path that exists between input and output that goes via between 1, 2, then through this 6, then it goes to this way, and then finally reaches 5. So this is another forward path that exists. No node is coming more than once. So the gain of that forward path is minus 1 multiplied by 2 by s plus 2. Minus 1 into 2 by s plus 2. So it is minus 2 by s plus 2. Second forward path gain. Now you need to identify the number of loops. So number of loops in this example, you can see this 3, 4 and this path via 6 and back to 3. So the path is 3, 4, 6 and then back to node 3. This is the loop. What is its gain? L1 is the product of 1, 3 by s and 2 by s plus 2. So 3 by s into 2 by s plus 2 is the loop gain. So it is 6 by s into s plus 2, 6 by s into s plus 2, and only one loop exists. Remember that this is not a loop, okay, and this one also is not a loop, because it has to complete where you have started and you must end there only. That is called a loop, and only one loop exists in the problem. When there are two forward paths, two deltas exist. First delta is equal to 1 minus sum of the loop gains. that is L1. So it is equal to 1 minus 6 by S into S plus 2. Whereas delta 1 is 1 minus sum of the loop gains which are not touching the first forward path. So this is the first forward path. So there is no loop non-touching that particular forward path. So it is again 1, delta 2 also 1. Now it is only a substitution for finding this ratio E of s by x of s is equal to 1 by delta into P1 delta 1 plus P2 delta 2. So substitution of the values P1, P2, delta 1, delta 2 and delta will give you the overall transfer function. So this is another problem on signal flow graph that appeared in the previous IES questions. It looks very simple that hardly you have any forward paths and hardly any number of loops that appear. Now the question is here, if you consider this y as output, and the question here is he asked y by x. So x is the node that is appearing in the middle. So what you have to do here is you find out y by r, that is overall gain, assuming y as output and r as input. You can find out this gain using Mason's gain formula. Then you find out x by r, assuming x as output and r as input, and then you divide this y by r by x by r, it will leads to y by x. So that way you need to get to solve this particular problem. So let us find out first what is y by r. What is y by r? Assuming y as an output, then you need to identify the forward path gains. So there is only one forward path from r to y. So that is P1. It is equal to the gain of this particular path. Gain of this path is 1, gain of this path is g. So it is 1 into g and it is simply g. Now no other forward paths exist. You need to identify the loops. Very clear, self loops. These are called self loops with gain minus h1. This is minus h2. So I say L1 is the loop gain, its value is minus h1, and L2 is the loop gain, it is minus h2. Now you need to identify any pair of loops which are not touching. You can see that this loop is confined to node x, this loop is confined to node y, and there is no connection between x and y. In the sense, those two loops I can say they are not touching each other. So the product of such loops, product of pair of non-touch loop that exist only L1 and L2. So I can say that they are not touching. So it is given by H1 into H2. Now what is delta? Delta is 1 minus sum of the loop gains L1 plus L2, then plus product of two non-touch loops, that is pair L1 L2 is the delta. So it is given by 1 plus H1 plus H2 plus H1 H2. This is delta. What is delta 1? delta 1 is 1 minus sum of the loops which are not touching the first forward path. There is only one forward path and both the loops are touching them, so it is 0, it is equal to 1. Now you can substitute this in the Mason's gain formula, that y by r is 1 by delta, this is 1 plus h1 plus h2 plus h1 h2, it is the delta value, and p1 is g and delta 1 is 1. So it is simply 1 into g by the denominator delta. So you got y by r now. Next you need to get x by r. To get x by r, this is 1. Now you need to get x by r. So in that case you should consider x as output and r as an input. So what is the gain of that path connecting input and output? So in this case the forward path gain P1 is simply 1, because there is only 1 here between this input and this output. So forward path is 1. Now what are the loops? Obviously loops are L1 minus H1, L2 minus H2. Now the product of non-touch loops, again L1, L2, it is equal to H1, H2. Now let us see what is delta 1. Delta 1 and delta. Delta means 1 minus sum of the loop gains as usual plus product of non-touch loops. It leads to the same of delta of the above case. So it is again 1 plus H1 plus H2 plus H1 H2. H1 H2. Now what is delta 1? It is interesting to see that delta 1 is 1 minus the loop gains which are not touching the first forward path. There is only one forward path, this one. So this loop is touching this forward path because connected to x, but this loop is not touching this one. So I can say that loop, second loop, this is L1, this is L2. So L2 loop is not touching this forward path. So that L2 exists here. So its value is minus H2. So it is equal to 1 plus H2. Now you need to substitute this in the Mason's gain formula. So x by r is equal to 1 by delta, that is 1 plus H1 plus H2 plus H1 H2 into P1. P1 is simply 1, but delta 1 is 1 plus H2. Now simply to get this y by x, you need to divide y by r divided by x by r. So you will get y by r as g by 1 plus H1 plus H2 plus H1 H2 divided by x by r means 1 plus H2 by this. So it comes in reverse into 1 plus H1 plus H2 plus H1 H2 by 1 plus H2. So this gets cancelled and g by 1 plus H2 is the gain, overall gain between y and x. So this way also the question may appear that how to find out in such cases using Mason's gain formula.